In this segment, we focus on how to name aldehydes and ketones using common nomenclature. If instead you're interested in learning about how to name aldehydes and ketones using the IUPAC system, take a look at videos immediately before this. That is video 338 for aldehydes, 339 for ketones, and 340 where we do some problem solving with IUPAC nomenclature. In this video, instead, we're going to focus on using the common names for aldehydes and ketones. While the IUPAC system is the universally agreed upon system for naming aldehydes and ketones, many of the so-called common names have very much made their way into our language so that they are used in many cases more frequently than the IUPAC system. And for that reason, we will discuss what common names you need to be familiar with for aldehydes and ketones here. Let's begin with the common names that you need to be aware of for aldehydes. This is by no way an exhaustive list of aldehyde common names. However, it is the list of common names that you need to be aware of for purposes of this class. And so let's go ahead and get started with that. Aldehydes. Formaldehyde is the simplest aldehyde that we can discuss. It's a common preservative in biology labs. For example, if you've ever done a dissection, chances are the organism that you were dissecting was preserved in formaldehyde with just strong antimicrobial properties, and also, as it turns out, is just quite toxic in general. Formaldehyde is a one-carbon aldehyde. A one-carbon aldehyde has hydrogens flanking both sides of the carbonyl. So here's our carbonyl group, hydrogen, hydrogen. So formaldehyde is a one-carbon aldehyde. The formula of formaldehyde then would be CH2O, and that is the simplest possible aldehyde that we can encounter. Going ahead and increasing the level of complexity by one carbon atom brings us to acetaldehyde. Acetaldehyde is a two-carbon aldehyde. We can go ahead and draw that out with our carbonyl group at one end of the molecule, making that aldehyde, and then a grand total of 2 carbons in our longest carbon chain here. So if we were to draw that out as a condensed structural formula, we could write it out something like this as our 2-carbon aldehyde molecule known as acetaldehyde with, to follow our trend here of writing out the molecular formulas for these, C2H4O as the formula for this particular molecule. Acetaldehyde is particularly relevant as an intermediate in the metabolism of ethanol. Ethanol becomes oxidized to acetaldehyde, which then gets further oxidized during metabolism to form acetic acid. So the term acetic acid refers to a 2-carbon carboxylic acid. Acetaldehyde, with that same beginning to the name of acete, refers to the aldehyde that has 2 carbons. Going on up the number of carbons by one more brings us to a molecule that has a total of 3 carbon atoms in the chain. So we'll go ahead and draw that out here, like so. We could also draw that out as a condensed structural formula. And you will notice in this condensed structural formula, just to show you a few different ways to represent things, that I've put the carbon and hydrogen right here and here shown with no line connecting the two, whereas over here I showed a line connecting the two. Either of those two ways is perfectly fine and acceptable as a strategy for drawing these molecules out. In the case of a 3-carbon aldehyde with a chain, such as what we see here, the common name for this molecule is propionaldehyde. So I will go ahead and write out that name for you. Prop for 3, ion, aldehyde. And there is, by the way, no ion in this structure. Ion refers to a charged atom. You see no charged atoms here, but propionaldehyde is the common name for this molecule, which would have the formula C3H6O. And then finally, last but certainly not least on our lineup of common aldehydes that we need to be aware of is the aldehyde which has 4 carbons in its parent chain here. This aldehyde shown here, which we refer to as butyraldehyde, B-U-T-Y-R, and then the word aldehyde, reminding us that this has an aldehyde functional group. Formula for this molecule is C4H8O. So these are the 4 aldehyde molecules that you should be able to recognize by their common names and apply that information. These are all biologically relevant aldehydes that play different functions in the body. Some are toxic substances. They're also common industrial chemicals as well, and so common, in fact, that they go not only by the IUPAC names that we should be able to assign for these, but also by these common names. You'll notice that in each case, the common name ends in the term aldehyde, whereas the IUPAC system has compounds ending in the suffix al. So for example, if we were doing the IUPAC name of a couple of these compounds, propionaldehyde would instead be referred to as propanal, referring to the aldehyde group. Butyraldehyde would be referred to as butanal, referring to the fact that it's an aldehyde. So you should be able to recognize both the IUPAC names for each of these molecules, as well as provide the common name or apply the common name toward drawing the structure of these. With common names of aldehydes now taken care of, let's turn to ketone common names. As we consider ketone common names, the rule that we will apply here for the ketone common names is that they will follow the template of alkyl, alkyl, ketone. What do I mean here? The 2 alkyl terms, here and here, refer to the alkyl groups that are bonded to each side of the carbonyl group. And we list these in alphabetical order. And I will warn you that in some alternative common terminology, these instead are listed in things like the order of molecular weight, where lower molecular weight is listed first, followed by higher molecular weight. So you may see some variations in how these alkyl group names are organized here. Regardless, what it's always going to mean is what's bonded to the ketone group. In other words, if we have our ketone group right here, then the alkyl groups that we are naming would be represented as R and R prime. So this would be one of the 2 alkyl groups. However many carbons is in that chain would be referenced as one of the alkyl names at the beginning of the common name. And the other one, the R group over here, would also be mentioned. These 2 would be listed in alphabetical order. So an example is worth 1,000 words, or something like that, however this story goes. So let's do an example of going about determining the common names of a ketone or 2 along the line here. So we'll go ahead and begin with this structure. We recognize it first off as a ketone because we have a carbonyl directly bonded to 2 carbons. That's the first thing to establish, is that you're actually dealing with a ketone and not something else. Now that we have done that, what we will do is map out the alkyl group bonded to the left of the carbonyl. That has 2 carbon atoms in a chain, so we refer to that as an ethyl group. On the other side of the carbonyl, we have a 3-carbon chain. We refer to a 3-carbon chain as a propyl group, so I'll plug that in as a propyl group. Now, what we will do is fill those names in alphabetical order. Ethyl comes before propyl, so I'm going to put ethyl first. So ethyl space propyl space, and then finally, as the grand finale, we got to remember that we have this ketone group here. So I'm going to go ahead and plug in the term ketone to finish off this example problem with a space between each word here. Now, when you're thinking about the molecular formulas of these molecules, what you will find is that the molecular formula will be equal to the number of carbons in each of the 2 alkyl groups plus 1 extra carbon atom, because we don't include that carbonyl carbon in either of these alkyl group names. The alkyl group doesn't include the carbonyl, it includes only the carbons away from that. And so ethyl propyl ketone, if we were to dissect how many carbon atoms are in that, the ethyl group has 2 carbons, propyl group has 3 carbons, ketone group, as the last part of that name, has 1 carbon, and so the grand total number of carbon atoms in this formula would be 6 carbons. Now, we can also apply this alkyl-alkyl ketone jargon toward molecules that have 2 identical alkyl groups, such as this structure here. In this structure here, you will notice the molecule has symmetry on both sides of the carbonyl group, where we have an isopropyl group here and an isopropyl group here. We call that an isopropyl group because it has 3 carbons and it's the carbon in the middle that connects to the ketone on both sides. So rather than calling this isopropyl ketone, what we do to streamline things is instead we just call it diisopropyl, di meaning 2, and there's 2 propyl groups. So diisopropyl, and then plug in the term ketone to indicate that those 2 isopropyl groups are bonded to our ketone group. So this would give us our full IUPAC, our full common name for this particular molecule, diisopropyl ketone being the full name for this molecule. We can also do this for examples that are a little more on the complex end. So what if we had a 5-carbon ring connected to our ketone group, connected to a methyl group? How would we go about naming that? Using common nomenclature. Using common nomenclature, we have our 5-atom ring here, which we refer to as a cyclo, indicating the atoms are in a ring, and then there's 5 carbon atoms, so it'd be pentyl. That is one of our 2 alkyl groups bonded to the ketone. Our other alkyl group bonded to the ketone right here has just 1 carbon atom, and we would refer to that as a methyl group. Plugging these names in, cyclopentyl versus methyl, would give us cyclopentyl, methyl, and then finally, the centerpiece of the molecule, our ketone group, I will plug in here in blue. So this would give us our complete common name for this molecule, where again, just like the other examples, we follow the template of naming each of the 2 alkyl groups, list those at the beginning of the name in alphabetical order with a space in between, and then tag the term ketone on the back end of the name to indicate that there is a ketone carbonyl group separating the 2 alkyl groups. You should be able to apply this common terminology toward naming relatively simple ketones, meaning ketones where each of the 2 alkyl groups has a common name that goes with it, such as isopropyl, tert-butyl, etc., or where it's a straight chain of 1 to 10 carbon atoms, where we can name it as methyl, ethyl, propyl, butyl, etc.